Hi folks, I'm Christian Brand. I work at Google and I'm part of the security and identity teams. I want to give you a little overview of what we've been working on over the last couple of months. With FIDO over the last couple of years, but then also what the changes are and which are the things that's going to be forthcoming here over, I guess, the next year or so. So before we get started, why don't we quickly just look at a recap of why we're doing the work that we're doing? Why are we so interested in FIDO and web authentication? So what's interesting is that phishing started to overtake malware on the web roughly in and around the 2014-2015 timeframe. And this is a slide that I've shown a number of times at conferences. Maybe you've seen this before. But what's kind of like odd about this slide is that it ends just after 2018. And when I've presented this in the past, the audience said, well, it's nice that this data kind of goes to 2018, but what heck really has happened since? Is phishing still such a big problem as what we've depicted here? So then I have this slide, and this is really kind of more active data that I've pulled from the Safe Browsing Google Transparency Report the other day. And what's really interesting here is it shows that phishing actually is still a major source of concern on the web. More interesting, I mean, there is a massive spike there around February, March, which I think coincides a little bit with COVID. Seems like the attackers also had to work from home, and they started to be a little bit more active there. But phishing over recent years have really just become the scourge of the web, right? It's the giant problem that we all have to contend with. And we think FIDO is really uniquely positioned to address this problem. So let's go back a little bit. Let's go back actually about 5 years to look at what we've been saying at FIDO and what we've been aiming for, and then try and fast forward again to today to try and understand if we've been able to accomplish all the things that we've set out to do. So back in 2015, this is a presentation that we've done to the FIDO Alliance as Google. And at that point, there was this kind of FIDO Unified Standard UFS that obviously later got renamed to FIDO 2 that we've been looking at. And UFS was supposed to solve all the issues that back in the day, the FIDO U2F and the FIDO UAF use cases couldn't quite get to. So UFS, or the Unified FIDO Standard, had this use case of built-in authenticators where users should be able to just use fingerprint sensors and facial recognition built into devices and make that available to any app or any website for authentication. Another use case that we looked at when we started and set out in 2015 with UFS was we wanted special purpose second factor adapters to also work for any relying party, any website, any service. And we wanted to allow those services to use this special purpose device as a second factor. Now, some of you might remember this as the traditional U2F or universal second factor use case, which obviously we also wanted to bundle into this new specification. So that's one use case that we were also trying to solve. And then there was a third use case that we were really interested in. And this was the use case of making your mobile phone, your smartphone, be a authenticator to any other service, right? So you're on your laptop or your desktop, you're trying to access a resource. And the idea was that you should then reach out to your mobile phone, which has your key material, your FIDO key material, you perform some kind of an action on this device, and then magically your laptop or your desktop is signed in. So those were kind of like the major 3 use cases that we had in mind for this brand new FIDO UFS standard. And the idea was that, a user enters an email and then the RP can look it up, the relying party on the server side. And there was kind of like a specific API that we have in mind, like kind of this get key API. And you can also see this was a long time ago. The Google logo has even changed in the meantime. But the idea was that we have this kind of an experience where a user goes, tries to sign in, magically on their mobile phone, something appears, they get a list of accounts, they can click it, and then, sign in as kind of like an example here. And again, we talked a little bit about how the API might look and how this might work, but this was all things that we kind of dreamt up back in 2015. Now, let's forward a number of years. Let's look at 2020. Which of these actual use cases came to pass? So the first thing that you might mention or notice here is that there's no more FIDO UFS standard, right? That got rebranded pretty early on as FIDO 2. So it's the same kind of use cases we had in mind, but with a slightly different name. And of course, this particular use case is one that we solved, right? The second factor use case, even in U2F was there. We got that into FIDO 2 with some backwards compatibility for older types of U2F keys. And this use case, worked pretty nicely. And it was implemented by a number of websites on the internet. Of course, Google implemented it, Salesforce, Dropbox, GitHub, a number of others that also implemented this particular use case. We actually went one step further in recent years. We actually added capabilities to this particular use case, which allowed users to verify themselves. So not only does a user need to be present in order to exercise the security key by just touching it, we're now looking for specific users to touch on this fingerprint sensor and authenticate the particular user. So we did even better than we originally set out to do. So that's really a pretty nice use case, and it kind of solves that problem where it has no UI and can't authenticate the user, because it really can authenticate users individually, either based on a PIN code that you enter or a user touching a fingerprint. It is really still suited very specifically to certain use cases like enterprise and high security, so it still hasn't quite cracked the code on general adoption of FIDO technologies. The other use case that we have is the use case of built-in authenticators, like being able to access a built-in fingerprint sensor or face recognition built into a platform, like for example the fingerprint sensor on Android, or the same thing on iOS devices, and kind of the same thing on Mac and Windows. And we've even solved this use case. Still a little bit cumbersome to set up. User would first have to enter a username and a password, their primary authentication mechanism, and then they can opt to use the platform authenticator. And once they've registered it, then yes, they can sign in passwordless using FIDO into that website in the future. But what really has remained a bit of a mystery here for us is the phone to laptop use case, right? That's still something that we're struggling with and something that we've been working on over the last number of years. And I want to give a quick update on where we are with this particular one. So the state of FIDO, just to recap in 2020, is that special purpose authenticators like physical security keys are really well supported, but they cater to very specific use cases. Mainly enterprise, high value use cases where users can overcome the burden of having to go out and buy a physical piece of hardware. Still hasn't quite achieved general adoption yet. Platform authenticators, they're available to a much broader audience. This is typically like Windows Hello that's built into the platform, or on iOS or Android fingerprint or face recognition. And that is kind of like seen a little bit more adoption. We have certain services like eBay, for example, that have adopted some of this. And even for Google accounts, some of these technologies are now available to our users. However, phone as a roaming authenticator, right? That use case that I spoke about, where you can use your phone to come to a laptop or a desktop and then use that to authenticate, that is the next focus area for FIDO. That's an area that we really want to explore going forward. And really, as a result of these, two implemented use cases, and then the third one that hasn't quite made its way in yet, FIDO just isn't as widely used yet as we would really like it to be. Passwords still are everywhere. We still haven't quite killed the password. So the question at this point is, what are we doing to change this, and how are we bringing FIDO to the rest of us? So with that, I want to introduce a specific new transport in FIDO. It hasn't been quite standardized yet. It is already introduced into FIDO as a pull request. There are certain changes that we're making to it and some experimentation that we've done that I'll talk about. But cable, or cloud-assisted Bluetooth, is kind of the mechanism that we think will solve finally that mobile phone to laptop use case. So a little bit of history again here. Back in 2019, Google launched this particular product. There's a link there to a blog where Google launched phone as a security key, or basically a security key built into a user's phone. We first launched it on Android and then subsequently on iOS. And the idea was that instead of a user having to go out and purchase a USB or Bluetooth or NFC security key, they could just use their phone as their security key for their Google account. And this used Bluetooth as a transport. So the mechanism was that when you want to sign in somewhere, you'd better have your phone handy, because if you can prove that you have your phone will communicate locally to your laptop over Bluetooth, over this cloud-assisted Bluetooth protocol. And the cool thing about cable or cloud-assisted Bluetooth protocol is that we didn't need any pairing between these two devices. So it would operate in a mode where the user can just try to sign in on a new device. They get a prompt on their phone. They click yes on the prompt. Magically, the phone would be able to find the laptop and then exchange basically FIDO CTAP data. CTAP is the protocol we use in FIDO where authenticators can talk to client devices on which you're trying to sign in. And we launched this product and we put it out there in the market. But the interesting thing is that there was some specific issues that we ran into with this protocol, which I'll get to. But before we get to that, let's kind of look at cable first. So the good parts of cable protocol is it uses Bluetooth, but it doesn't require any explicit pairing, as I said. Pretty nice. You just kind of use the phone, and automatically the phone and the laptop would find each other, and that's kind of all baked into how the protocol works. You also needed no state on the laptop. It just works, right? There's no pairing, as I said. The bad part of cable v1, the one that we've implemented, is that it cannot work with discoverable credentials. So those of you that's familiar with FIDO and how FIDO works, that essentially means that you can't have username-less and maybe to some extent passwordless flows. You'd still have to enter a username and maybe even perhaps a password, and then use the phone as a second factor. And a lot of interest lately has been in FIDO as a total replacement for usernames and passwords. So we know we needed to do a little bit better than what we've done with cable v1. The registration had to happen on the phone, so you had to register the credentials on the phone. You couldn't do it elsewhere and then over Bluetooth do registration. Relying parties needed to support this protocol outright. There was some extra magic that they'd have to do. And then another issue was the way in which the laptop and the phone would find each other is by broadcasting a specific EID over Bluetooth, and this EID would be controlled by the relying party, and that is a bit of a privacy concern. So we wanted to do a little better than what we've just done with cable v1. Also, once we launched cable v1, we learned a lot. And that was kind of one of the most interesting pieces here, is that the success rates for cable v1, platform and phone communication, are at best around 95%. And at worst, around 75% with some larger platforms, where this can mostly be ascribed to kind of like finickiness with Bluetooth, where maybe the phone and the laptop, they use obviously adapters from different OEMs, and we just ran into a bit of issues regarding Bluetooth stability between the laptop and the phone. And these kind of success rates were something that we really wanted to improve upon. So not only did we want to improve some of the cons we had stated earlier with the protocol, like the fact that you can't use discoverable credentials and the fact that there was a bit of a privacy issue, but we wanted to push this further forward, right? So we wanted to kind of figure out if there is a way to come up with a protocol that can solve some of these issues as well as some of the reliability problems we have here. So in the next step, we're working on a version of cable, particularly called cable v2, which has less dependence on Bluetooth. Now, we still use Bluetooth in this protocol as a way to establish proximity, because if you understand how FIDO works, you'll know that proximity is built and baked into the FIDO protocol. It's very important for the laptop and the phone, the two devices, the one on which you're trying to sign in, and the authenticator, the mobile phone, to kind of prove to each other that they are in physical proximity. That is really the way that we address the phishing problem, right? Without the proximity checks, the kind of the phishing promise of FIDO, or the phishing resistance promise of FIDO, is not kept. So it's important for us to know that these devices are physically proximate, and the way we do that is by still using Bluetooth to establish that these two devices are in close proximity. But then in the next step, when it actually comes to the data exchange, we then move most of the data exchange, we offload that to the cloud. So the idea is that we take the best parts of Bluetooth and then kind of build upon that and not rely so much on Bluetooth for data transfer, which is where most of the Bluetooth issues actually come in. So the cool thing with this protocol is that it will work with discoverable credentials. Credential registration does not have to happen on the phone. You can do it somewhere else and then over Bluetooth do it to the phone. RPs don't have to explicitly support the protocol, which is really cool. If a relying party or a website or a service today implements WebAuthn, when this technology becomes available, they can just make use of it, right? There would be no explicit work that they'd have to do. If they support WebAuthn, this will just become available to them as another authenticator, which they can then support automatically almost. And then broadcasting EIDs is not specified by websites, right? So it's kind of controlled here, where the earlier potential privacy issue is then kind of circumvented here. So that's really cool, and something which we hope to achieve with this brand new protocol that we're working on right now inside of the FIDO Alliance. So with all that, why don't we quickly look at the user experiences that's enabled by using cable? So here is a couple of quick screenshots of how, and this is kind of like all obviously just exploratory mockups, but this is technically how cable version 2 can be utilized in a way to give you these kind of like typeless experiences where users don't have to enter usernames or passwords and they can authenticate in a completely phishing resistant way, right? So this is a user, they're coming to their brand new laptop that they just bought, they're opening it up and they want it set up, and they just see this QR code suddenly appearing on the screen. Now the user knows that they can go and grab their phone, and on their phone they can open the camera and they can just scan this QR code. And the reason for scanning the QR code is for these two devices to know they want to now talk FIDO to one another. So that's kind of the first trick here, is we want to communicate or set up a channel between these two devices. So the user takes their phone, scans the QR code, and at that point, a message pops up on the device which says, hey, are you trying to communicate with your Surface Book? Are you trying to set that up? And if the user then says, yep, that's exactly what I'm trying to do, they show their face, touch their fingerprint, whatever local authentication mechanism exists on the device. And at that point in time, magically, they are just signed in. So what happened here is the laptop and the phone found each other by virtue of scanning a QR code. Then a Bluetooth connection made sure that the laptop and the phone is in close proximity. And then we exchanged all of the rest of the data via the cloud, and that then allowed the device to sign the user in. So all of the FIDO data was really transmitted through the cloud. But it doesn't really matter because Bluetooth still proved to us that these two devices are in close proximity. So that's kind of like one of the really cool use cases that we can now do and which we're aiming for. So completely, usernameless, passwordless, discoverable credential use cases possible with this new protocol, Cable v2, and it's something that we're working inside of FIDO Alliance, which you'll certainly see a lot more about over, the next couple of quarters. So to end off with, what can one do today? Well, implement WebAuthn right now. I think some of the cool things that I mentioned here is that even if you implement WebAuthn today, and when these new, Cable v2 and Phono security key technologies become available in modern platforms, you don't have to change your implementation. If you've implemented WebAuthn, you magically can just make use of all of these new authenticators as they become available. Here's a couple of links of things you can check out. IBM is a great FIDO server running that's implementing a bunch of different use cases that you can get started with today. You can play with Google's FIDO server. You can play with a code lab that we've got going at Google, and I know later in the conference there will also be a code lab from AG from Google that you can participate in. And lastly, but certainly not least, please check out the How to FIDO project on GitHub here, where we go through a bunch of different use cases in FIDO in greater detail, which will also help you get started if you're a relying party interested in implementing any of this on your own website. Thank you very much.